This is problem number 12 for section 3.3. In this problem it says, find the derivative of all orders of the function. So what they want us to do is they want us to take the derivative of this until we end up with 0. So that's our goal, is to take the derivative until we end up with 0. So we have a fourth degree power, so we at least need to take the derivative 4 times. Let's start by doing dy over dx. When I take the derivative of y with respect to x, I bring the 4 to the front, so it's 4 times x to the 4 minus 3 over 4 plus 7 over 6 times 3, because I bring that power to the front, x to the 3 minus 2, or 3 minus 1, minus 2 x to the 2 minus 1 plus 7, because this will be 7x to the, well, this would be 7 times 1, x to the 0, right, when we subtract 1 out, so it's just 7, and the derivative of the constant just cancels. I can go ahead and distribute here, and this 4's cancel, and I'm left with x to the, oh, it shouldn't be 4 minus 3, that should have been 4 minus 1. Sorry, 4 minus 1, which is 3, plus, this will be 7 over 6 times 3, the 3 and the 6 cancel, and I'm left with a 2 on the bottom, so I get 7 halves, x to the second power, and then this will just be minus 2x. And then I have plus 7. Now I want the derivative of y, so the second derivative, the derivative of the derivative. So the second derivative of y with respect to x, well, that's just going to be 3x subtract 1 squared. When I bring the 2 to the front, I take 2 times 7 halves, which will cancel the 2, so I just end up with plus 7x, because I subtract 1 from the power. Derivative of negative 2x is just negative 2, and this will be 0 when it cancels out because I take the derivative of a constant. The derivative, or the third derivative of y with respect to x, I bring the 2 to the front, that's 6x when I subtract 1, plus 7. Derivative of negative 2, the constant, cancels. I do the fourth derivative, so the fourth derivative of y with respect to x. A derivative of 6x is 6. Derivative of 7, 0. And so I end up with then the fifth derivative of y with respect to x. Well, the derivative of this constant is 0. And so you can see we have all the orders here. We have the first derivative, the second, the third, the fourth, and the fifth.